Today, we're going to dive into the hidden world of chemistry. We're talking about the science behind all the changes that are happening around us every single day. Let's get right into it.
It seems like such a simple question, right? But it's actually one of the most fundamental questions in all of science. Why does a shiny new bike eventually get rusty? Or why does that fresh food in your fridge go bad? The world is always changing. And the answer, well, it's usually chemistry.
Just take a look at these two pictures. On the left, you've got corrosion, good old rust. And on the right, rancidity, which is just a fancy word for food spoiling. You might look at these and think they have nothing in common, but they're actually two sides of the very same chemical coin. And by the end of this, you'll know exactly why. So let's start by looking at where these transformations, or what scientists call chemical reactions, actually happen. And trust me, you're going to be surprised by just how common they are.
Think about it. Milk souring on the counter, the way iron rusts outside, even the digestion that's powering your body right now. Yeah, the simple act of breathing, that's just a whole series of super complex chemical reactions. And fermentation, turning grapes into wine, that's chemistry too. These reactions aren't just happening in some high-tech lab. They're happening in your kitchen, inside your body, and all around.
Okay, so if these reactions are happening everywhere all the time, how do we even spot them? Well, it turns out chemical reactions leave behind little clues, kind of like a detective story. You just have to know what you're looking for.
All right, clue number 1, a change in state. The classic example is a candle. You start with solid wax, right? Then it melts into a liquid, which then turns into a gas that burns. That whole transformation, solid, liquid, gas, that's a huge sign that a chemical reaction might be going on.
Next up on our list, a change in color. This one's usually a dead giveaway. When you cut an apple and it turns brown, or when a bright green leaf turns fiery red in the fall, you are literally watching new substances being created, and they just happen to have different colors. That is a chemical reaction in action.
And our third big clue is a change in temperature. I mean, you felt this one for sure. Some reactions get hot, they release energy. We call those exothermic. Think of a big roaring campfire. But others actually get cold. They absorb heat from their surroundings. Those are called endothermic, like what happens in one of those instant cold packs. Either way, if the temperature changes, it's a huge hint the chemistry is at work.
So, we know how to spot a reaction, but how do scientists actually, describe them? How do they write it all down? Well, they use a kind of universal language, a recipe for change, if you will.
It's called a chemical equation. And honestly, the best way to think about it is exactly like a recipe. The stuff on the left of the arrow, those are your ingredients. We call them reactants. That arrow in the middle just means makes or turns into. And the stuff on the right, that's your final dish, the products. It's a really clean and simple way to map out a pretty complex process.
Okay, let's look at a real classic. Here we have magnesium, or Mg, reacting with oxygen, O2, to make magnesium oxide, or MgO. Looks pretty straightforward on the screen, right? But what does this actually look like in the real world? And bam, this is what that little equation is describing. It's the burning of a magnesium ribbon. The metal combines with oxygen from the air, and it creates this incredible, brilliant white light. And what's left behind is a totally new substance, that white powder, magnesium oxide. That's the power of a chemical equation. It captures this whole crazy dynamic event in one simple line of text. Now, here's the really cool part. Even though there are millions of possible chemical reactions out there, almost all of them fit into just a few basic patterns. So let's check out 4 of the most important types.
First up, we've got the combination reaction. This one's super easy to remember. 2 or more things literally combine to form one bigger, more complex thing. In this example, calcium oxide joins up with water to make calcium hydroxide, and it lets off a ton of heat. It's simple. A plus B equals AB.
And next we have the total opposite, the decomposition reaction. This is where one big thing breaks down into simpler parts. A perfect example is what happens when silver chloride sits in the sunlight. It just decomposes, breaking apart into solid silver and chlorine gas. So AB breaks down into A plus B. See? The opposite of combination.
All right, now for a couple of swapping reactions. In a displacement reaction, that's the top row, you have a more reactive element, in this case iron, that comes along and just kicks a less reactive one, copper, out of its spot. But in a double displacement reaction on the bottom, it's more like they trade partners. See how the sodium pairs up with chlorine and the barium teams up with sulfate? It's a full-on swap.
Okay, now we need to talk about a really crucial concept that powers so many reactions. It's called oxidation and reduction,
or redox for short. Now, the simple way to think about it is that oxygen is gaining oxygen and reduction is losing oxygen. But what's really going on deep down is a transfer of electrons. One substance loses electrons, that's oxidation. The other one gains them, that's reduction. They are a package deal, they always happen together, and they are behind some of the most important changes we're about to see.
And that brings us right back to where we started. We've learned the clues, we know the language, we've seen the main patterns, so now let's use all that to finally crack the case on those everyday mysteries. Remember that rusty iron from the beginning? Well, now we know exactly what's going on. We call it corrosion, but on a chemical level, it's just a slow and steady oxidation reaction. The iron is reacting with oxygen in the air, losing some electrons, and forming a new substance, iron oxide. You know, rust. Mystery soft. And what about our spoiling food? That rancidity? You probably guessed it. It's also caused by oxidation. The fats and oils in the food react with oxygen, which changes their structure and gives them that nasty taste and smell. Isn't that wild? It's the same fundamental process that makes a car rust, just happening to your potato chips.
So, as you can see, this isn't just some abstract thing you learn about in science class. Chemical reactions are literally everywhere, constantly building things up, breaking them down, and rearranging the very stuff that makes up our world. They really are the invisible architects, shaping everything around us.
So that leaves us with one final thought. Now that you know what to look for, the clues, the patterns, just take a look around you. In the coffee brewing in the kitchen, the battery charging your phone, the leaves changing color outside your window, what unseen reactions are happening all around you right at this very moment?